Hello everyone! Today, me and my friends from Group 3 of Computational Thinking class will present our work regarding case study number 6. My name is Melina Zifania from Industrial Engineering. So we will be presenting a simulation program for an autonomous drone delivery system, which is our case here. And the background is that the rise of e-commerce and the company struggle to operate drones in urban environments. So the program that we model will help with delivery drone operating day by day and make decisions automatically based on various conditions, be it obstacles, weather conditions, and also to manage battery life. So this is the program that we have made. It starts by classifying the drone class, and then we also classify the route manager, and also the simulation class. Oh wait, this one is to map out the route, the chosen route, and also the simulation class. And we also created a loop to make sure to ask the user if they ever want to input another simulation. So this program will simulate daily delivery operations and considers key factors like weather conditions and obstacles that may affect the route. It also manages the drone's battery stages intelligently, deciding whether it needs to recharge. And it starts with a battery of 100%. It also allows users interaction to input daily delivery parameters and runs the simulation continuously until stopped, which is the loop. And by running the simulations, users can see how drone adapts its behavior every day based on input conditions and make smart decisions to complete deliveries while managing resources effectively. It is a very practical tool to explore autonomous drone concepts. And here is an example of the outcome. So here it is. For day 1, we enter if it is good or bad weather and if there is any obstacles, and because there is an obstacle, we use another route and it will deliver based on the priorities. And that's it.
Hello everyone, my name is Madya Putri Aryawan and I'm from Industrial Engineering. So now I'm going to explain a Python class called Route Manager, which is designed for manage and selects delivery routes for a robot or a drone based on weather, obstacles, and priority. And it also helps choose the best path and visualize the delivery route from the base to the houses. So let's start with the init method. So this method, it defines 3 route options, which is short, long, and alternate, each with time and battery usage. It also sets coordinates for the base and 3 houses. And then the next function is the select route function. This function chooses the best route based on weather and obstacles. If both conditions are bad, it cancels the delivery. Otherwise, it picks a longer or safer path depending on the situation. And then the third function is visualize route. This builds the path based on the delivery priorities. It starts from the base and visits the selected houses and then returns to the base again. So, in short, this class helps automate route selection and path planning for deliveries, adjusting to real-world conditions like weather and roadblocks. So, that's all for the Route Manager class. Thank you.
Hello everyone, my name is Tarisha Kayan Jacksono. I'm from Bioprocess Engineering. I'm from Group 3 Computational Thinking class, and today I'll be explaining the study case 6 for the plotting part. So how it works is, this is to understand the delivery path taken by the drone and to identify which houses were visited. It's also to verify the route chosen based on weather and obstacles. So for this first part, this is to retrieve the XY coordinates for all locations in the path. So it will show up the XY coordinates over here. And it will also print if the coordinate for location is not found. So for the next part, this plot figure, this will initialize a new figure and plots the full route with the circles for waypoints and blue lines between them. So later in the output, it will show a graph which shows the route taken by the drone with arrows and labeled coordinates based on weather, obstacle status, and delivery priorities. And then for this I in range code, this will add directional arrows from one point to the next, which this will shows the flow of the route. It has the arrow style and also the color of the arrow. This will define the house coordinates. It will show up in colors and labels, which if the color is blue, then the location is en route, and if it's not, then it will show up in the color gray. And this will also label each house with its name slightly above the point. And then this next code is for the plotting. This will add titles and axis labels, which has the x coordinate and y coordinates, and it will show the grid. And then it will show block if it's false. Then it will pause this for 6 seconds for the next plotting, and this will also closes the plot. So for the next part, this part of the code handles the daily operation of the delivery system. It connects the drone class and route manager class, and will also simulate weather, obstacle, route selection, and battery update. So in this part, this will initialize the drone and route manager objects. This will initialize the day to keep track of the current day in the simulation. Then for this next part, for the function is, it will run a simulation for 1 day. If it's equals to 1 or more day, it will increase the day count, and if it's delay, then it will recharge needed. And then For this route, this will choose a route based on current weather and obstacles. This will cancel delivery if both conditions are bad. And it will also print if the battery remaining and the delay due to the recharge. And that's it. Over here, you get more route details and also display the updated data that I stated, which has the battery remaining and also the delay due to recharge. That's it. Thank you.
Everyone, my name is Felicia Andina. I'm from Chemical Engineering, and today I'm going to discuss our study case, which is case study 6, Autonomous Delivery Drone System, and I'm going to discuss the looping part. So how it works in our drone delivery system, this is the looping part, is that at the bottom of the code, we have this section that runs the program. It starts by greeting the user, whether we want to start the simulation or not. If we say yes, then the looping will start, and if we say no, then it's going to end. Sorry, it keeps scrolling upwards. So overall, you have these inputs, which is whether you deliver or not, the weather condition, if there's an obstacle or not, and the house priorities. So to discuss it more technically, we have 3 pieces of input, which first is weather condition, obstacle presence, and delivery priorities. And then after collecting all the valid inputs, we print out the delivery details and call the method sim run day. Where was it? Somewhere here. Oh, here. And then it does several things, which increases the date count. And it checks if the drone needs to recharge. And if yes, it does so and adds a 30-minute delay. And then it selects the appropriate route based on the weather and obstacle using the route manager class from earlier. And if the route is not canceled, it visualizes the delivery path using the plotting from earlier, which drains the battery based on the route's usage. And finally, after that day's delivery simulation is complete, we loop back to the start and wait for the next set of inputs. The user can keep going or type exit at any point to stop. So overall, this looping structure acts as a simple day-by-day simulation engine, handling user inputs and managing conditions and progressing the drone's status over time. That's it for the looping part. Thank you very much.
Hello, my name is Danta. I'm from FG3, and after my friends has explained the chunks of the code from the class, the illustration part, and then the loop input, now I'm going to show you how our code runs or what is the actual output of our code. So we're going to start it. After we press start, there's going to be a title of Autonomous Delivery Drone System Control Panel. So first, do you want to start the simulation? In this example, if we said no, it will stop and say simulation ended, goodbye. Let's start again. Do you want to start the simulation? Say yes. When we say yes, we enter a new day, so we can see here. And then the code will ask us to input a couple of things. First, do we want to deliver? Obviously, yes. Second, it's going to ask about the weather condition. The weather condition will affect the battery level and also the route of the drone. Let's say in this example, it's good. And obstacle. This will relate to the battery level. Let's say yes. Let's say no. And then we can input the priority list of the house that we want to deliver to. I'm going to type from house 1, house 2, and house 3. After entering those inputs, we're going to be given an illustration. This is the illustration of the priority list based on the coordinate system of each house. After displaying the input for 6 seconds, it's going to ask for another input. So it's going to loop forever. Let's say in this example, we say yes, and then we say it's bad weather, and yes, there's an obstacle. And then our priority list, let's say it's still the same, house 1, house 2, and then house 3. House 3. Delivery is cancelled due to bad weather and obstacle. Based on the code, if there is a bad weather and also an obstacle, the delivery for that day will be cancelled. Moving on to the next day. So delivery, yes. Let's say that the weather is good. And then let's say there is an obstacle. For the priority list, let's change it up from house 3 to house 2, and then last, house 1. Now, this is completely different from the first illustration. As we can see, it is started from house 3 first and then to house 1. Also, we can see that the output there is the battery remaining of 30%. Each delivery, the battery will be used. And if the battery hits 0 or below the recharge level, it will have a delay. So let's continue. Deliver, yes. Is it good or bad weather? Let's say bad. And then is there an obstacle? Let's say no. And for the house priority list, I'm going to change it up again. House 2 to house 1 and then last house 3. Okay. We can see now that this is a completely different illustration compared to the last two. We can see that now the battery remaining is 0%. But the delay is still 0 minutes because the battery is 0%, the next delivery will have a delay, as we can see here. Yes, good, no. And then for the house, let's keep it the same, like last one, which is house 2, house 1, and house 3. It will make the same illustration as before because the priority list is the same, but there is a delay of 30 minutes due to the recharge of the battery. We can see that the battery now is recharged to 100%. Now, if you don't want to deliver, we can type exit or just no. Simulation ended, and then it will give us the final battery status. So that is all from our group. I hope our code is up to the standards of the study case. Thank you so much. Goodbye.